Okay, past paper questions on P1 trigonometry. The first question says, let's solve this equation giving the answer in exact form. Okay, so this sine inverse of 3x is minus pi by 3. So this 3x is going to be sine of minus pi by 3. Please remember that sine of minus theta is same as minus sine theta. Okay, and then cos of minus theta is cos theta, and your tan of minus theta is minus tan theta. Okay, so therefore we can say that this 3x is going to be minus sine of pi by 3. And if you remember, you should always remember the sine's critical values, okay? What is sine 0? That is 0. What is sine pi by 6? That is half. What is sine pi by 4? That is 1 over under root 2. What is sine pi by 3? That is under root 3 over 2. And then what is sine 90? That is going to be 1. So you must remember these values, because you see examiners want you to give the answer in exact form. This is minus under root 3 over 2. So your x is minus under root 3 over 6. Okay? So this was 4a. Then we have 4b. Okay, this 4b is, we have to factorize this. You see that I can take 2 cos theta common from here, and I'll keep it as it is. So this is 2 cos theta into sine theta minus 1. And I can take just a minus common from here. That is sine theta minus 1. That is equal to 0. So we have sine theta minus 1 into 2 cos theta minus 1 equal to 0. So guess what would happen next?
We'll equate both of them to 0.
Yeah, so we have 2 quadratic equations out of it. So now one is going to be sine theta minus 1 equal to 0. So this is the domain within which we have to find the value of theta. So theta is sine inverse of 1. Okay, and you see that this is going to be the answer here. So your theta is going to be pi by 2. And then we have the next one. Okay. The other part of this equation is 2 cos theta minus 1 equal to 0. So cos theta is equal to half. For this, you will have to mark these quadrants, okay? And you people should know that here it is, sine is half at pi by 6. So cos will be half at pi by 3. Okay, so you can use your calculators if you want. And then you have this theta as pi by 3. And
We'll
then,
only use pi by 3, sir, because it's only till pi. The range is only till pi.
so that is going to be 5 pi by 3.
No, I'm saying we won't take the 4th quadrant because the range is only till pi. It's not till 2 pi.
Oh, yeah. Thank you very much, beta. This is just pi. Oh, so you have just one answer. If it was 2 pi over here, thank you, beta, for reminding us. Thank you. So if it was 2 pi, then you could have these two answers. So right now, this is the only answer. Thank you for timely reminding this thing. I just ignored that pi over here. Okay. Okay, guys, this question is from March 17, paper 12, and the fifth question. Now, by looking at this diagram here, you must not be getting scared, because you should be used to this tan x graph. Okay, the only thing, the tan x graph, missing over here. That is the asymptote thing. Okay, we have the asymptote at pi by 2. Just going to make you recall that tan graph. Okay, then you pi by 4, and I mean the intervals of pi by 4. Okay, so tan 0 is 0, and at pi by 4, tan is 1. So this part goes like this. Then tan pi is 0, tan 3 pi by 4 is minus 1. So this graph, this part goes like this, okay, with the asymptote down. If I complete this, so there should be next asymptote at here 3 pi by 2, and you see that you must be able to recall this, okay. And then the second graph over here, that is for the cos x. So I can write 1 here, I can write minus 1 here, okay. If I had to complete this graph for the tan x, I mean for the cos x, so this should have gone like this. Yes, guys? Did you recall this? I think you should change the color
Yes.
so that you can see that. Yes, this looks nice. Ah, yes, this is 2 pi here. This is going to be 3 pi by 2. It's pi, this is pi. Anyhow, I have tried to make you recall your graphs. Let me complete the graph for tan here. This would be the asymptote here. Though it's not required in the question that you have to complete this, but I still want you people to recall it, okay? So I think 2 pi should be here. Somewhere here, okay. So this is, according to the scale, it is like this, okay? Anyhow, I've completed the sketch from 0 to 2 pi, okay? Okay, but so it says find by calculation the x coordinate of A. So here is this point A. So obviously, if you can solve two equations simultaneously, you can get the same solution that you can see that happening graphically. Okay. So if suppose you had to solve these two equations graphically, so it's been done over here. If this was drawn on a graph paper with a proper scale, then you could guess, okay, what is going to be this value. Anyhow, let's solve this simultaneously then. So we have to equate both the y's. So tan x, that is going to be equal to cos x. So what is the problem with this equation here? But so if you people know how to solve the trigonometric equations, yes. What is the problem here? Anyone, please be quick. We are recording it. Yes.
We don't have the same function throughout.
Exactly. Very good, Beta. So we have one side is showing tan x, the other is showing the cos x. This is very annoying thing. We should have only the sine or the cos or the tan in our whole equation. Okay. So let's try to bring in one color in this whole equation. Okay. So I'll have to change the tan x with the sine x over cos x. Okay. So this will give us sine x equal to cos square x. Okay, so which one we can change into the other, the sine x or the cos square x?
Cos square x.
Why? Why do you think so?
1 minus sine square x is equal to cos square x.
Because we have our favorite identity, sine square x plus cos square x, that is equal to 1. So we can easily change this cos square x into with 1 minus sine square x. Okay, so this is going to be sine x equal to 1 minus sine square x. So we move them, all of them, to the left hand side. So this is going to be sine square x, sine square x plus sine x minus 1 equal to 0. And then if you can't solve this through factorization, you should quickly use the quadratic formula. Some of you might like to change this sine x with the y. So the equation would become y square plus y minus 1 equal to 0. And then they can apply the quadratic formula here. This is minus 1. Please tell me quickly, what do we get after applying this quadratic formula over here? This is minus 1 plus minus under root 5 over 2. Yes, Bacho, what do we get?
0.618 and minus 1.618.
Tell me again.
0.618.
Okay, 0.618 and
minus 1.618.
thank you, beta. Okay, minus 1 plus under root 5 over 2. And this one is y equal to minus 1 minus under root 5 over. अच्छा बच्चों, ideally the ones who are aiming for the top in the word, they should keep this value with them, okay? The ones who are happy with the B or the C grade, they should the rounded values for the upcoming working, okay? So since we're looking for a positive value, so and the first value, so I'll be taking this value, okay? So this y is my basically sine x. I don't have to solve, I don't have to find all the values up to this pi, or I like, you know, there's a point B as well. So he might ask us to find this point B in the next part. So let's find both the parts here. So I'll not be taking the minus values because, you know, your sign is positive into these two quadrants, okay? And if I take the minus values, I'll be going to the third and the fourth quadrant. Okay, guys, what is sine inverse of this 0.618 or this minus 1 plus under root 5 over 2? Yes.
0.666.
In radians. Yes, beta, what is this?
0.666.
0.6?
Yes, like 3 sixes.
All the sixes, okay. Yes, so I can put a dot here. Is it rounded to the third significant figure, or we still have to round it
Yes,
off?
it's rounded.
Okay, this is round. Thank you.
After that, after this, it's not said there's no dot because after this there are more numbers. So
Okay,
there won't
so
be
I
a dot.
don't want to put. Okay, thank you, Beta. So, so this is 0.666. So that is the x. We only have to find the x coordinate. Don't try to find the y coordinate here, okay? And by the way, this was not a good substitution here. Why? Because y is already being used here. So again, we should use, instead of y, we could have kept a, b, c, d, whatever. But try to avoid using a letter that is already being used in the given situation here. Okay? So is that clear? How did we find this x coordinate to the point A?
Yes, sir.
And what would be the x coordinate to the point B, by the way? So
Pi minus.
yeah,
It would be 2.48.
in case he wants the point B. So what is pi minus this?
2.476.
So
Which
this
is
is
2.48.
2.48, comma, whatever. We're not interested in the y coordinate, okay? So let's see what is there in the B part of this question. So much space given. Find by calculation the coordinates. Oh, now he wants you to find the coordinates of B. So that means he's interested in the y coordinate as well, okay? So you had two equations, guys. One was y equal to tan x, okay? The other was y is equal to cos x. So in any of these equations, if you put your x coordinate, you will be getting the corresponding y coordinate. And this will be interesting to see that the both of them should give you the same answer. So please put half of you put your x into this y to tan x, the other half put into cos x. You will see that you must be getting the same answer. Yes. Do we get the same answer?
Yes, sir. Minus 0.78.
Can you please speak a bit loudly? Yeah, minus?
0.78.
Minus 0.7. You must give this correct to three significant figures better.
786, 0.786.
Okay. So is it the same in both the equations? Yes or no?
Yes,
Yes,
sir.
the same.
Okay, so this should be the same in both the equations. So you see that you have solved two equations simultaneously. Before this in your lives, you have been solving equations like this: 3x plus 2y equal to 4, 2x minus y equal to 6. And when you entered into your A levels, the next equation was like this: x square plus 2xy minus y square equal to 5. Okay, but now you have solved two trigonometric equations simultaneously. Okay, let me see if there is any third part of this question. No, there is no third part, so we can move to the next question then. Okay, the third question, this is from the March 18 paper 12. This is an easier question because there's only one problem, that is the tan x we have to find. Okay, so here we go. We start with the cross multiplication. This is 5 plus 2 tan x, that is 1 plus tan x times 3 plus 2 tan x. Now, since there's only the tan x in it, so you can like right away you can start this. Oh, no, he says as a quadratic equation in tan. So we have to simplify this first, and then we will substitute this tan x with something. So this is your 5 plus 2 tan x, that is 3 plus 2 tan x plus 3 tan x plus 2 tan square x. Okay, and then you have, I'm moving these terms on the left hand side to the right hand side. Okay, so we have 2 tan square x. This 2 tan x can be cancelled with this 2 tan x. Okay, so plus 3 tan x minus 2, that is equal to 0. So we have shown that this can be written as a quadratic equation. And then if you want, you can say, okay, let this tan x is equal to, you can keep it as a. Okay, so we have 2a square plus 3a minus 2. I can factorize this. I can factorize to the middle term breaking. Okay, this is 2a square plus 4a minus a minus 2. So I have 2a into a plus 2. Guys, you have to show this working where you solve this quadratic equation. So don't just try to find this directly through the calculator, okay? Don't lose your marks. So this is a equal to minus 2 and a equal to half. So then you put this a back as tan x. So you have tan x equal to minus 2. Since again, I will not be ignoring this thing here. We have to be within the first two quadrants, okay? So this will be in this quadrant, okay? So can someone tell me what is tan inverse of 2?
1.107.
Thank you, 1.107. And so this is going to give me pi minus this. So what is this correct to three significant figures?
2.03.
Thank you, beta, mashallah. Okay, and then the second one here is going to be this tan x equal to half. So this will be clearly in the first quadrant, no plus minus thing here. So what is tan inverse of half? Yes?
0.464.
Okay, now there is one thing, but you have to be very clear. But so whenever we have this pi thing over here, remember your calculator's mode should be in radians. Okay, in fact, most of the times your calculator's mode should be in radians. We rarely have to use the angles in degrees as far as the pure mathematics is concerned. Okay, in your mechanics, mostly it is like the angle is in degrees, okay? But in pure mathematics, we mostly deal with the radians, okay? So,
Sir,
yes, Mira? Yeah?
sir, हम -2 को नहीं करेंगे calculate.
But because of this -2, we have marked this quadrant here. So that is, don't try to find tan inverse of -2. Before you use the calculator, you should have this diagram with you, okay? You must have marked the quadrant where you think that your angle is going to lie. Okay? Okay, so that is it from the first half. Let's go into the second half, guys. This is the question from June 03, the first paper. It says find all the values of x in the interval from 0 to 180. Okay, so be aware of this 180, which satisfy this equation. Okay, now the equation is sine 3x plus 2 cos 3x, that is equal to 0. So I can see two problems in this equation. Who will tell us that what are those two problems here? Yes, quickly, bacho.
We don't have the same function and the angle is 3x.
Yeah, we don't have the same trigonometrical ratio. Like we have the sine x and the cos x in the same equation. So there should be one of them. And secondly, the angle is a composite angle over here. Okay, so let's make this a trigonometric equation with a simple angle over here. Okay, so I would say let 3x is equal to alpha. So this equation becomes sine alpha plus 2 cos alpha equal to 0. And I should mention the limits for the alpha as well, where alpha is going to be between now, in this relation here, in this relation, you put the lower limit of x, which is this 0, okay? So when I put 0 here, so I get alpha's lower limit 0 as well. And then I put the upper limit, which is 180. So the 3 times 180 is going to be 540 degrees. So that means when you find this angle x, sorry, this angle alpha, so that has to be between these two limits. Okay, now the equation has the sine and the cos in it, so it's a typical situation where you have only two terms and they are both in sine and cos. There is no factorization that can take place. There are no squares on these sine or the cos. So the only way to handle this is to divide the whole equation by the cos alpha. Okay, so you must show this step that we're going to divide the whole equation by the cos alpha. Okay, both the left hand side and the right hand side. So this equation now becomes this is going to become tan alpha plus 2, that is equal to 0. So your tan alpha is going to be minus 2. So tan is negative in these two quadrants, okay? So this and this. Keeping your calculators mode in degrees, can someone tell me what is tan inverse of 2? You see, I'll be writing it as minus 2, but I'll be finding the tan inverse of 2. Yes, what is tan inverse of 2?
63.43.
63.43. You must, this is not the final answer, okay? So you try to keep this as accurate as you can, okay? So now remember within this limit 0 to 540. So one of the values of alpha is 63.43. The next one is 360 minus this. So that is going to be, Patana zara,
296.5.
297 maybe, okay, and there should be a third value as well. Now please see, what is 360 plus this value? Do we stay within this limit or do we cross this limit? Yes.
423.43.
Oh yes, that's fine. 423.43. Yes. So if you add 360 into this, you will be definitely crossing this limit of 540. Okay. So these are the three values of alpha we have. Now we were actually finding.
Sir?
Yes, beta.
Why is the first value 63.43? Shouldn't it be 180 minus 63.43?
Oh yes, yes, absolutely. Oh, you saved us from making a disastrous mistake. Yeah, this was the value to be given. Thank you, beta. So what is this value? 180 minus this?
116.57.
Thank you, beta. Thank you. Again, very timely. Like you'll see, I had marked this correctly, but I just ignored this while writing the answer here. I did keep that in account while giving this value, but I just forgot for this. Okay. So now if you add 360 into this, 116. What do you get?
476.57.
Okay, 476. So that means it's okay now. So these are the three values that we have, okay, for alpha. And now we need to have the actual values, which are the values of this x. So 3x was equal to alpha. So x is going to be alpha by 3. So you divide all these values one by 3 and tell me what are these values correct to one decimal place. Yes, 116.57 divided by 3. What do you get?
38.8.
9.
38.9.
Okay, 38.9. And the next one, 296.57 divided by 3.
98.9.
98.9. And the last one, 476.57.
158.9.
158. So you see that we have these three values within this limit over here. Okay. Okay, guys, that's it from the past paper question session on this trigonometry of P1. Okay. So maybe tomorrow we can discuss the questions, all these questions that we have done in this term so far. Thank you very much.